Diameter of a circle, radius of a circle, area of a circle, circumference of a circle, sectors, all these are parameters associated with a circle. Today, we'll get friendly with these terms associated with circle and learn more about it. You are with Have Fun and Learn. I am JP Dutta. If you're new to this channel, please subscribe, comment and share. That will inspire me, and also you'll get notification about my future videos. So let us go on. Here we have a circle with center O, right? Now if you draw a line like this, correct, which cuts the circle at 2 points, and the points lie on the circumference of the circle, this will be called, this line, say L is called a secant. So that's what L is. Now the moment I specify a particular segment like A and B, this becomes a chord, correct? So what is the definition of a chord? A chord is a line segment whose two endpoints lie on the circumference of the circle, right? Okay. Now see, we talked about area, perimeter or circumference and its relation with radius and diameter. Let us get what is diameter. See, as you increase, as you go up, the length of the chord increases. See, now when it passes through the center, say CD, it has got the maximum length and it will decrease as you go up, correct? So the largest chord of a circle is called its diameter. So let us get the two definitions correct. So definition of a chord, correct? What is that? A line segment whose two endpoints lie on the circumference of the circle. Now let's say what is circumference, right? I'll come to that right now. So this is the definition of a chord, right? Now if we want to define diameter is the largest chord of a circle, right? So here it is CD, correct? Is that part understood? Now when we talk about largest chord, so we call this largest chord as D, right? So if you call largest chord D, so D is equal to diameter is equal to D. Now half of the diameter like this or this is called the radius. So half of the diameter is known as radius, correct? Understood? So if we write a relation, if the diameter is equal to d, then radius r is equal to d by 2, correct? From here we can write twice of r is equal to diameter. So that's two relations you have got. Okay, so this is all about diameter and radius. Now how these two parameters help us in finding out the area and circumference of a circle. Okay, let's find. Now the circumference of a circle is the fencing, the black line. So when you try to find out the circumference of a circle, it's given by C is equal to twice pi r, right? Where C is equal to circumference of the circle r is equal to radius of the circle. Now see, r is equal to d by 2, correct? So we can write C is equal to 2 times pi into d by 2, and that you can write is equal to pi into d. Now the area of the circle is denoted by the space enclosed within it, right? So the area of a circle is equal to pi r square, right? Where r is equal to radius. Now we know that r is equal to d by 2, right? So we can put this here instead of r. So a will be equal to pi times d by 2 whole square. Now if you are talking about the value of pi could be equal to 22 by 7, which is more often than not used. But if you are asked to, in a question, asked to use pi is equal to 3.14, you can jolly well do that. Now see, AB is a chord, right? Now when you talk about this side, the larger side, this is called the major segment. The major segment of the circle, correct? And this one, the small segment, this one is called the minor segment of the circle. Why I mentioned about the segments, please remember this, it will come to use when we learn the theorems that are associated with circles. Then it will come to use. So we have got two segments, correct? Now see, if we join this line like this, you create an angle, right? Let that angle be theta, right? This is the center O. Now, the angle created by joining the two endpoints of the chord is known, is very important. What is the name of this particular angle? Is known as the angle subtended by the chord at the center. Now in saying so, we are missing a point. What is that? Now if you call this C, this part, get it, this part is called an arc. So ACB, it is denoted like this, is an arc, right? So similarly we can say the angle here subtended by the arc is also theta. That means the arc also subtends an angle theta at the center because the points are A and B, they are same, correct? So this is a very important part that I wanted to stress on. So what we know, when you join the two 8 points with the center, you get an angle theta, right? This angle theta is called the angle subtended by the chord or the arc at the center. Now suppose we got an arc ACB and the angle subtended at the center by the arc ACB is theta. Right, now this part, so AOB is known as a sector, right? Now since it is in the, see this angle is theta, so this will be the major sector, right? And this will be the minor sector, correct? Now see what is the significance. We know that the area of a circle is pi r square, meaning thereby, see the angle subtended around the point is 360 degree. That means an arc of 360 degree produces an area of pi r square. So the area of a sector is given by theta by 360 times pi r square. You get it? Unitary method. 360 degree gives you an area of pi r square. It's like this. 360 degree describes the area of pi r square, right? So 1 degree will give you an angle of pi r square by 360, and if it is theta, it will be multiplied by theta, right? So this is simple. So the area of a sector, is equal to, okay? Now similarly, with the help of the angle subtended at the center, we can find out the arc length, right? We can find out this. We know that the circumference of a circle C is equal to twice pi r, right? So that means an angle of 360 degree describes a path of 2 pi r, right? So how do I get ACB? So length of the arc of the arc ACB will be given by theta by 360 times 2 pi r, right? That is the arc length. Okay, so this is what you have got about. Now, to recap things, let us find out what you have done. We have understood what is the diameter of a circle. We have understood what is the radius of a circle. From then on, we have understood how you find out the circumference, the area, what is a segment, what is a major segment and a minor segment, what is a sector, what is the arc length, and how we find out the area of sector and arc length, right? So that'll be all for today, and we pick up next class and we continue with the circle, and then let us see if you can pick up some typical problems from maybe R.S. Agarwal or some previous paper, so that we can do that and understand how these work in real-time problems. Till then,